Hello. So let's talk about digital logic. In particular, let's talk about the transistor. So you're used to devices so far in electronics that have two ends, a resistor, a capacitor, a switch. And the switch has sort of this extra input, which is generally your finger pressing down on the switch to tell it when to be closed and when to be open. What we have is an electrical version of a switch, so that a circuit can throw the switch on another circuit. That device is the transistor. So the transistor has three attachments, not two. The two are the top and bottom here, where the current will flow if the switch is activated. And then this is the control. How do we make this switch work? We make the switch close and current can flow when we put a high voltage here. And it doesn't flow when there's a low voltage or zero. When I say high or low, what we usually do in digital circuits is we mean 5 volts or 0 volts. So if we put 0 volts here, the switch is open, nothing flows. If there's 5 volts here, the switch is closed and it's like a wire. All right, so that's the basic gadget, the transistor, and we're going to build logical circuits out of it. So here's the first example. So if you have a wire that's connected to 5 volts and a wire that's connected to 0 volts, we can attach a resistor and a switch. Okay, so we know that if we were to connect, like so far there isn't any other wiring, so we're still going to have to reach in and do it by hand. If we take a wire and we attach it to there, current will flow. But if we instead take the wire and attach it to here, then current will not flow. Those are our two options. Now, an interesting thing happens if we consider how many volts we get here. Let's have a wire coming out, and we're going to call this X, and the input, we're going to call that A. If the current is running, then this is like a wire, and you are connected directly to 0 volts. So current running here means you get 0 volts at X. So in make the current run, we need to attach to 5 volts. So if there's 5 volts here, there will be 0 volts here. But if we connect this to 0, this switch is open. It's not actually connected to 0. Well, is it connected to 5? Well, there's a resistor here, but the resistor has no current through it. There's no path. If there's no current, V equals IR. If I is 0, the voltage is 0. And remember that V is a delta V. So there's no difference between X and 5 volts, which means X is 5 volts. So if A is at 5 volts, X is at 0 volts. If A is at 0 volts, X is at 5 volts. So we have a code for this. We say that 0 volts counts as a 0, and 5 volts counts as a 1. And that's the beginning of binary arithmetic in circuits. So we consider this A and X, maybe sort of what we call a truth table. If A is 0, then X will be 1, and if A is 1, then X will be 0. And this is called a NOT circuit. All right, that's the first kind of logical circuit. The next thing we're going to do is attach two transistors. We can put them in series, we can put them in parallel, and we can get things like AND circuits and OR circuits. And we'll cover that next time.